Hi, everybody. I'm tired. I don't want to go to bed, but it doesn't matter because we got to talk about congruent triangles. All right. So, as you know, congruent things, same size, same shape, right? I said this before, but I bet no one remembers. I'm going to say it again. Um, we get equal. This means equal. This little wavy sign means similar, which is the same shape. Equal means same size. And so congruent is same size and same shape put together. All right, so congruent polygons, same size and same shape, and they have corresponding parts, just like the corresponding angles. You see, B corresponds to J. I could see that right away because they both have one arc. A corresponding not with K. This K has three little arcs there, but with H, did everybody see that? And then even the sides have a matching corresponding side, right? So make sure you know in the two triangles or polygons which parts are corresponding. Very important. And then we write this thing called a congruent statement. All right, so when I tell you to write a congruent statement, I'm not saying sign your name and say that they're congruent. I am saying to write it like this. Triangle ABC is congruent to triangle HJK, and then A and H are corresponding parts. B and J are corresponding parts. And C and K are corresponding parts. Not only that, but side AB corresponds to side HJ, and side BC corresponds to side JK, and side AC, first and third, corresponds to side HK, first and third. So just let that sink in. All right, so what do we got here? Show the polygons are congruent by identifying all the corresponding parts, then write a congruent statement. All right, so I'm just going to write a congruent statement here for all right, so these are quadrilaterals. So I'm just going to write the letters. So A, and then W, and then I'm going to go to B, and then after W, go to the two at X, A, B, C, D, W, X, Y, Z. Just happens to be alphabetical. All right, so that is called a congruent statement. Check out Goss, there he is. He made many advances. All right, it's a good guy there. All right. Ooh, see, this is my favorite thing. CPCTC. What does that mean? Corresponding parts of congruent triangles are congruent. So if we know the two triangles are congruent, then we know their corresponding parts are congruent. If we know, if I tell you that triangle LJK is congruent to triangle Q. All right, now I gotta figure this out. LJ, so QPM. Then if I tell you that, then you could say by CPCTC that angle L is congruent to angle Q. Now, couldn't you? Your reasoning would be CPCTC. All right, there you just did your first CPCTC proof. You didn't even know it. Okay, in the diagram, RSV is congruent to TVS triangles. Find the values of X and Y. All right, so then we know RS is congruent to TV. And so we could write that T2Y minus 1 equals 24. And of course, the X is congruent. So then So then this is 90 here, 78 here. And so, 90 and 78 makes 8, and 168, and then 168, 1 minus 180, and that's 12. So x is 12. Hopefully you see that. And then add 1 to both sides, and 2y equals 25. Y equals 12.5. So there you go. Just a little algebra. The third angle theorem. Of course, yes, of course. If we know that angle C is congruent to angle K, and furthermore, we know that angle B is congruent to angle J, well, that only leaves one angle pair, and they must correspond, and they must be congruent. Please write that down. The third angle theorem. Okay. All right. Real world example. In the diagram, all right, so we want to find NWR. We want to find that if I knew it, WX is a bisector and WNX is 88. WNX is 88. And NXW is 49. NXW. I find NWR. NWR. Well, we're going to be able to figure out this one. And then we're going to know this one is the same as it. So then we can just multiply by 2. Hopefully you can do that. Third angle theorem. All right, let's do the proof. So they've done the proof actually already. So let's look at it. So it's got the given and then the reflexive property. All right, take note of the reflexive property. These two triangles share side EF. So even though it might seem silly, if we want to prove that two triangles are congruent, we need to say their angles and sides are congruent, right? And so we have this is given, and then this is reflexive. We're also given the angles here, and then the third angle theorem says that those angles are congruent. And now we've said all 3 angles and all 3 sides. So the triangles are congruent. Definition of congruent polygons. All sides and angles have corresponding congruent pairs. Okay, so now I'm going to write my own 2-column proof, but not before making a little, marking it up a little bit. I see some vertical angles, right? Everyone see the VAT happening right there. And then JLPL, that's marked. Now, oh, and L is bisecting KM. So we're going to be able to say definition of a bisector for KL being congruent to MLM. All right, so let me just go ahead and try to prove this thing. So my given information is quite abundant. J is congruent to P. And then JKPM. And then JL and PL. And then L bisects KM. So much given. All right. So we got that. Then let's just call the angle 1 and 2. So then I'm going to say angle 1 is congruent to angle 2 by the vertical angle theorem. And then furthermore, we can say KL is congruent to LM. By the definition of bisector. And then said everything we need to say, so we can say JLK is congruent to triangle PLM. And the reason is definition of congruent polygons. Woo. All right. Yep. Remember the reflexive property, not necessarily of triangle, but of segment congruence and angle congruence. Okay. Now let's see. I want to do 4-4. Now just as soon as you do 4-3, you get to 4-4. And in 4-4, they're now going to tell you that you don't need every side and every angle because there are some shortcut theorems. Isn't that nice? If you know that the sides all have congruent corresponding pairs, that's sufficient to say the triangles are congruent. The angles will also have the pairs. It has to be that way. All right. And so this is called side, side, side triangle congruence. You can read it there. All right. So I assume we're going to use side, side, side to show that these two triangles are congruent. And what are we given? QRS is isosceles with QR and SR. So I'm going to mark that in the picture. And RT is bisecting QS at point T. So I'm going to mark that in the picture. And that's all we need. Okay, so now we got, just write down our, watch this shortcut here. Given, we're going to forget that's there. I'm going to, now 2, I'm going to, so what did I mark? I marked the QR and SR. The reason is, what was the reason? Definition of isosceles. All right, that was because we had an isosceles triangle. And then QT, ST. And who knows why that was? That was because of the bisecting. So I'm going to say definition of bisector, or just bisect. And another statement there, TR is congruent to TR. Why is that? That is the reflexive property. Congruent. So we have the transitive property, now the reflexive property. And guess what? This is a side pair, side pair, side pair. So once we've made 3 side statements, now we can say what I originally crossed out, which I can't read anymore. It says QRT. QRT is congruent to triangle SRT. And the reason is, all right, side, 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 triangle congruence. All right, side, side, side on the coordinate plane, we're going to use the distance formula. So we will look at that again. Did we? I'll play a song for you. I sung it. It's a song. Don't you worry. We'll be singing. All right. So that's the distance formula, we could just use that to show that the corresponding side pairs are congruent, as they did there. After that, well, if they were congruent, we could say they're congruent by side, side, side. But as you can see here, they didn't all work out. What a shame. Anyway, all right. Then the last thing we're going to talk about here is side angle side. So side, 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 and side angle side. What is that? It's all about the included angle, or the angle between two congruent sides. All right. Like the angle of a clock, as it says. Okay, so you can see B is an included angle and E is an included angle. It's between those two congruent sides. So, all right, I'm going to do 2 more proofs and then I'm going to sleep. All right, so the wing, after I do the dishes, the wings of the hang glider appear to be congruent. All right. So FGGH, FGGH, that's marked. And then JG is bisecting. JG is bisecting that angle. So we know that that's congruent. And then JG is congruent to itself, reflexive, right? Let's write the proof. All right, I can see it. So if FG is congruent to GH, FG is congruent to GH, given, and JG bisects angle FGH. That's a given. 3. Do my angle 1, 2 again. Angle 1 is congruent to angle 2. Definition of bisector. And also JG congruent to JG. What's that reason? Reflexive property. And then we've said enough. We've said a side, we've said an angle, and we've said a side. So we can say triangle FGJ is congruent to triangle HGJ. And the reason is side, angle, side, triangle, congruence. All right, so that is how that goes. Now let's just oh, we gotta do it. Okay. Okay. So this one, we're not proving that the triangles are congruent as a last step. There's one more step after it. So let me show you. MN and PN is given. And then also, let me just LM and LP. Okay, so that's all given. So then we can say Ln is congruent to itself. Don't let a proof go by without including the reflexive property. Right? All right, so now we know the triangles are congruent. So we can say triangle LNM is congruent to triangle LNP, LNM, LNP. All right, and the reason is side, 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 triangle, congruence. Since the triangles are congruent, I can say angle LNM is congruent to angle LNP. And the reason is they're corresponding parts of congruent triangles. So CPCTC. You only say CPCTC after you've said the triangles are congruent. All right, I will see you in class.